Here we have the question of the cube, which is of 30 mm edges. It is cut by a sectional plane so that the true shape of the section is a regular hexagon. You note that in this question, the angle of the sectional plane is not given. Instead, it is said that the true shape will look like a regular hexagon, which means that the true shape is of 6 equal sides. In fact, we are supposed to find the inclination of the sectional plane with HP. We must also measure the length of the sides of the regular hexagon that is formed on the true shape. Let us see how we are supposed to solve this problem by drawing it. Firstly, we'll consider an XY line, and since it is first quadrant, we'll consider VP by HP. On HP, the plane figure of the cube has to be drawn in top view, which will look like a square. Either you can draw edge or corner condition, but here in this particular problem we'll consider the corner condition. Since the true shape is supposed to be a regular hexagon, we will consider the corner condition. So we can draw two 45-degree lines by considering a grid point, and we know that the length of side is 30 mm. Take 30 mm in your compass. You can measure it with the grid sheet itself and cut two arcs, and continue in drawing two more arcs to get the intersection, then join the lines to get the square in the top view. Now the square is done in the top view. We have four corners, and since it is a cube, we'll have the top and the bottom points. We'll name them as AA1 and continuously. We'll generate the front view from here by drawing projection lines from all the four corners. Do not forget to mention the dimensions of the sides. Since it is a cube, the height will be the same as that of the edge length, which is 30 mm, and we get the front view of the cube. You can complete the naming with the top face points without 1 and the bottom face points with 1. Also mention the height. The true shape, which is a regular hexagon in this case, is to be generated on the right side by cutting the solid at different cut points. If you just recall to one of the problems that was solved in the previous video, you will see that these were the edges that were present in the cube, and the cut points were identified in 5 different edges. And we got the solution of true shape in this manner, where we have only 5 edges and 5 cut points. Right, the 5 cut points 1, 2, 3, 4 and 5 were identified in the true shape of the section. While here we need a regular hexagon as a true shape, which means that there should be 6 cut points in the true shape of the section. These 6 points will give us a hexagon in which all the sides will be of the same length, which we do not know what is the length of that regular hexagon. So we need to cut this particular front view of the cube so that we get 6 equal edges in the true shape of the section. So which are the cut points that are to be identified to get the true shape of the section as a regular hexagon? Now if you refer all the elements that are present in a cube, 4 base, 4 top and 4 longer edges exist. Totally 12 edges, out of which 6 edges are to be cut so that we get the regular hexagon with 6 points in the true shape of the section. Here there are 2 edges, AB dash and AD dash. We'll select the midpoint of this particular 2 edges. Now let us see which way we are supposed to cut the sectional plane. If I cut like this, you're going to have 2 cut points over here, and if you're cutting it vertically, you will get 2 more cut points over here, totally 4 cut points. But we are supposed to get 6 cut points. So this way of cutting is not possible. If we cut the other way around like this, we'll get 3 cut points. 1 over there and 2 over there, totally 3. So if we cut like this, we are going to get 2 plus 2 plus 1. So totally we'll get 5 cut points, but still we are not able to get 6. So we need to get the midpoint of 6 edges so that we get the 6 cut points. So we'll locate the second midpoint over here vertically, where we'll mark it as 3 dash 4 dash, and inclining it to the bottom base midpoint of B1 dash C1 dash and C1 dash D1 dash, we'll get another 2 points, 5 dash and 6 dash. So now if we join these 3 points with a straight line, we can call this one as a sectional plane. And here the upper part will be removed and bottom part will be retained. So show the arrows in the downward direction like this. Now since we need a regular hexagon of 6 equal sides, we will find out 6 midpoints as we have done here. Let us see where these cut points have appeared in the cube. The 6 edges we will identify by listing out all the edges that are present in a cube. the base edges, top edges, and the longer edges. Check each edges and note down if the cutting plane is intersecting the edge. If it does, and whatever point that we have marked in the sectional plane, we'll highlight that point in this list of edges. Once it's done, the remaining edges have no cut points. Now let us find out the angle at which the sectional plane is cutting the cube by using a protractor. And when it's measured using a protractor, we get an angle of 55 degrees. To generate the true shape of the section, we can use a set square. Hold the scale aligned with the sectional plane and hold the set square in this manner and draw perpendicular lines from the cut points in this way. Draw a parallel line from the sectional plane at a convenient distance. We can name that line as x1, y1, which will be our reference to generate the true shape. Now before we generate the true shape, we must project all these cut points to the top view. 1 dash was obtained on AB, so we'll mark it there. In the same manner, mark all the remaining points in the top view. You can refer to the list of edges that were done where the cut points were identified. We can mark those points in that particular edge in the top view by drawing a projection line from the front view. Once this is done, we can join all these 6 cut points by straight lines, and this will give us the sectional top view. Now since the bottom part of the sectional plane is retained and the top part is removed, we must highlight the bottom part in the top view as well. After the retained portion is darkened in the top view, we can highlight the sectional top view by hatching it with 45-degree hatch lines. Hatch the area only covered with the cut points. Now with this, we can generate the true shape by measuring each cut point from xy line to the top view, that is xy line to 1. Cut the arc on from x1, y1, and there you will get the point 1 in the true shape. Repeat the same for the remaining points. Measure it from xy line and cut the arc from x1, y1 line on that respective vertical line drawn from that cut point. After getting all these points in the true shape, we can join them with a straight line since it is a cube. And once we join all this, hatch it with 45-degree lines, and that will give us the true shape of the section. It is also asked in the question to measure the length of the regular hexagon that we get in the true shape. And as you measure all these sides, you are approximately getting 23 millimeters in the true shape of the section. Make sure you hatch this true shape of the section with 45-degree lines equally spaced with thin lines only. That will give us the true shape of the section for this particular problem.